Hello everyone, my name is Aditya. In this video, we'll see how to fade an LED. So we'll see how to vary the intensity or brightness of the LED by making use of PWM outputs. So PWM stands for pulse width modulation, and Arduino UNO supports some of its pin in digital I/O for the PWM. So we'll see the circuit connection required for the project, and we'll also program the Arduino UNO to fade an LED. So first let's see the materials required. We need an LED, an Arduino UNO, jumper wires, a resistor. I'm using 1 kilo ohm. If 330 ohm is available, you can use that. We'll also be needing a USB Type B cable to connect the Arduino UNO to the computer, and of course we need a computer to program the Arduino UNO. So first let's see what is PWM. PWM stands for pulse width modulation. So this is a way of effectively reducing the voltage level supplied by a digital I/O pin. So we can achieve this by varying something called as a duty cycle. So a duty cycle refers to the percentage of time the signal is on in a cycle. So let's see what is a cycle first. So this diagram it's called as a waveform. So in the first waveform we can see two green lines. So the time between the two green line is called as one cycle. So we can see that in one cycle in the first waveform the signal is 0 volt. So that's why it's called 0% duty cycle. That means 0% of the time the signal is on. So in the second waveform we can see the 25% of the time the signal is on in a cycle. That's why it's called 25% duty cycle. So in the third waveform we can see that it's on for 50% of the time. So that's why it's called 50% duty cycle. So in the fourth waveform the signal is on for 75% of the time in the cycle. So that's why it's called 75% duty cycle. And in the last waveform we can see it's on for the complete time duration of one cycle. That's why it's called 100% duty cycle. So let's say that we need to reduce the brightness of an LED by 50%. So we can make use of 50% duty cycle by using something called analog write. So analog write is a function which is used to supply a PWM output from a digital I/O pin. So this is a function analog write. So this is a syntax. So we need to define the pin and the value of the duty cycle. So 0 corresponds to 0% duty cycle and 255 corresponds to 100% duty cycle. So Arduino supports 255 levels of duty cycle from its pin, and we should use a syntax which is displayed here. So analog write pin comma 0. So what this will do is it will make the pin as to supply a PWM with 0 duty cycle. So analog pin comma 255 refers to this pin will supply 255, that means 100% duty cycle. So if we want 50% duty cycle, we need to write pin comma 127. So all PWM supported pins of Arduino is marked with the tilde symbol in the digital I/O pins. So the supported pins are pin number 3, 5, 6, 9, 10 and 11. So now let's see the circuit and how to program the Arduino.
For the circuit part, connect the LED onto the breadboard, the positive end on the left and the negative end on the right, and to the negative end connect a 1K resistor, just like this. And then for the positive, connect to a PWM output, which is pin number 3. And for the negative, connect to ground. So that's it for the connection.
Okay, let's see the programming part. So firstly we need to define a PWM pin. Hash define LED pin. Let's say pin number 3 because on pin number 3 a PWM output is available. Then we need to make it as an output pin. So we make use of pin mode LED pin comma output. So that's it for the definition. So at first we'll try to let's also define another macro for intensity. Let's call it int. And first let's say we'll give 255. That is a maximum intensity. So in the void loop we make use of analog, right? Analog right LED pin comma int. So what this basically does is it will give a PWM output with intensity 255 onto the pin number 3. So first let's compile this. So as we can see it's done compiling. Let's try to upload this onto our board. Okay, so as we can see the red LED is glowing with max intensity. Let's try to reduce this intensity. Let's give it 127 and try to flash the same code. And if you can observe, it reduced its intensity. Let's try to give intensity 10. Okay, so as you can see the intensity is reduced. So now let's try to increase the intensity slowly from 1 to the maximum, the 255. So for that we make use of a for loop. For int I is equal to 0. So we'll start with the lowest intensity. I is less than or equal to 255 and I plus plus. And then inside this we'll try to write, instead of int we give I. Okay, so what this will do is it will start from 0 until 255. It gives the PWM outputs. So let's give a delay of 100 milliseconds. Okay, so let's try to flash this onto the board, and you can see once the flashing is done, you can see the intensity slowly increasing from 0 to 255. Okay, so let's make it 30 and we'll try to reduce the intensity. So in the first for loop we went from 0 to 255. So in the second for loop we'll go from 255 to 0 and I minus minus. So we'll upload this one and we can see that the intensity slowly varies from 0 to 255 and then from the maximum 255 to again 0. Okay, so that's it for the tutorial on how to fade the LED from 0 to max intensity and then from max intensity back to 0. So you can play around with it. If you want more delay you can add more delay, and if you want the intensity to vary with more steps you can just vary this I++. You can vary it by 2 steps or 3 steps. So right now it is just varying by 1 step each time all the way to 255. If you want you can vary in 2 steps or 3 steps. So just we need to give a step count here. So that's it for the tutorial. Hope you liked the video. Stay tuned for more such projects and tutorials. Thank you.